Okay, hey guys, this is lesson 10, conjugated and isolated alkadienes or something. Let's start with this one. As always, this video that he had was actually really helpful too. I have some notes, so when we're looking at conjugated, they have like a single bond in between them, and then it seems like when we have isolated, they have two or more single bonds in between them, so the double bonds are isolated from each other in a way. And then when we have no absorption above 200, so like a small amount of absorption, it means it's isolated. But when we have when we see here the longest wavelength of absorption, this actually means we have a conjugated molecule. So let's start by drawing what we know are penta, 5 carbons, 1, 2, 3, 4, 5, and then I'll go ahead and add my methyl to the 2 position, and then I'll put my double bond. I have 1 and 3, and then 1, 2, and then 3 going to 4. And then I'll add my hydrogens. Arrange and fit. So this one is pretty straightforward. It's just having you name that. But actually what I see is that this is conjugated, so this should be right actually, because longest wavelength means it's a long wavelength. But it was isolated, it wouldn't be above 200, so this should be good. I'm just checking my notes. It looks good. So remember, conjugated means that there's just one single bond in between these 2 bonds, so they're not completely isolated from each other. If it was isolated, this bond could be like over here and they would be isolated from each other. So longest wavelength, conjugated. Short wavelength, isolated. Okay, so let's move this around. I'm going to use my smallest numbering scheme. I'm going to read left to right. That's why I move this to the left. So I got 1, 2, 3, 4, and 5. I've got penta dash. I've got a double bond at the 1 position. 1, 2, 3. So at the 3 position, and then I have di because it's 2. I'll go to the front to add that methyl at the 3 position, so 3 methyl. And then I'm looking for chiral centers or anything of that sort, but I don't see any. And I'm also looking for like an E or Z conformation, because with these we have to do that. And I see right over here on the 3, so we're actually going to have a conformation. We're not going to specify that it's on 3 because it's only 1. So if it was on both of them, then we would specify, but since it's only on 1, we can just leave it with the parentheses. And now we're going to do a conformation. So I'm going to split this down the middle in my head. And then on this side, I have my highest priority, my methyl up here, and my lowest on the bottom. So I'm going to remember that this is 1. I'm going to go to the side. I have my greatest priority here, and my smallest one over here. So I have my greatest here and my greatest here. So that means I have an E conformation. So I'll do E3 dash methyl penta 1,3 diene. I'm just checking my notes to make sure that I did it right. It looks right to me. Okay. These can be tricky because it's hard. It's really hard when you have so much on the canvas. And the reason I didn't get a confirmation here is because we have 2 H's, so they're the same priority. So there's not going to be an E or Z confirmation as compared to this one that has 4 different things attached to it. I'm going to turn this. So for this lesson, you're going to want to be looking out for E and Z. I don't think we do anything with the RS in this lesson, so just keep an eye on for E and Z, and you should be good. So longest carbon chain, 1, 2, 3, 4, 5. we've got our penta dash. I have a double bond, 1 going to 2, so I have 1, and then 3 going to 4, so I have 3 dash diene. And then I have no methyls, and I'm just going to check that confirmation because I do see that we have, so this one, we have 2 hydrogens on the side, so we can ignore this. It doesn't have a confirmation. This one has a methyl and a hydrogen, and then a hydrogen and an ethene. So we're actually going to have to find if it's E or Z. And this one's pretty obvious because we have our highest priority on the bottom, and then on this side we have our highest priority on the top. So that means it's going to be E. So I'll do my dash, put it in parentheses, opposite sides is E. If this was on the bottom, it would be Z for same or same, because it'd be on the same side. And guys, if I'm ever talking too fast, you can always change the playback speed. I don't know how that'll sound, like all slow, but feel free to do that. Okay, so I'm going to start by drawing my 3-methylpentane. It says pentane, so I'm going to draw it single bonded first, and then I'm going to add what looks like 2 double bonds. So I'm going to start, pentane stands for ane, stands for single bonds, ene stands for double bonds, and the Y in E stands for triple bonds. So I'll draw my pentane 5 carbons and my methyl at the 3 position. Now I see there's no absorption above 200. So this is a short wavelength, which means that it's going to be isolated. So I'm going to want my double bonds as far away from each other as possible. I'm not going to put it on the methyl. I'm going to avoid that because either way it would make it conjugated, but that would be pretty unstable if I put it here. So I'm going to put it on this side so that they're isolated from each other, and then I'm going to put one on the opposite side. I'll then add my hydrogens. And that should be good to go. Oops. Make sure not to draw any extra carbons on the canvas. Okay, that looks good to me. So when it says it doesn't go above 200, it's a short wavelength, it's isolated. If it's a long wavelength, that's conjugated, and it would be right here and right here. They'd be closer apart, closer together. Okay, so with this one, you want to get the longest carbon chain that includes all of the double bonds. So I'm not going to include this one in the longest carbon chain. This is going to be an extra thing that I add in the beginning of my name. So I'm going to have 1, 2, 3, 4. So I have buta. And then with the smallest numbering scheme, I'm going to look, since I have these on the same side, I'm actually going to take into consideration where this ethyl is. And since it's closer to this one, I'm going to have this as my starting one. So I'll turn it around so I can be reading left to right. So I have a double bond at the 1 position, and 1, 2, 3 at the 3 position. Put my dash and my diene, and then I'll go to the front, and since we already turned it around, it's 1, 2. So I have 2 ethyl, buto 1, 3 diene. And the reason we don't want to do here is because it'd be 1, 2, 3. So it'd be 3 ethyl butadiene, but we want the smallest numbering scheme, which is why I started on this side. Lastly, I'm going to check for E or Z, but I can see that we have 2 hydrogens on this side, which means there's no confirmation. And then I can turn this one around and see that we have 2 hydrogens on this side as well, which means we have no confirmation. So I'm going to leave it like this and hope for the best. Okay, no absorption above 200, so we know that it's a small wavelength, so it's going to be isolated. So pentadiene, it's not being specific of where it is, so, but this is what tells us where the double bonds are, which means it's going to be isolated, which means they're going to be as far away from each other as possible. I'm going to put 1 at the 1 position and then 1 at the 4 position. Add my hydrogens and we're all good to go. Okay, I'll start with my penta. Got my 5 carbons, and then I have, oh, it's the same molecule that we just drew. So I have 1 going to 2, and then 4 going to 5. Add my hydrogens, and it's the same thing, just this. So what I have on my side right here is just, it says like conjugated, long wavelength, isolated, no more than 200. So I recommend having something like that and having something where it says like check the conformation, because that'll really come in handy with this one. So longest carbon chain, I don't see any methyls, so we're gonna count the whole thing. 1, 2, 3, 4, 5, 6. We have hexa. I'll start adding my double bonds. It looks like they're both at the 2 position, so I can start counting from here. 1, 2, so 2, 3, 4, so 4. I only have 2, so I can put diene. I'll come to the front and look for any conformations. I know we don't have any methyls because everything was just in the chain, and we're gonna have conformations because they all have different like sides. Like this one has a hydrogen and methyl, this one has a hydrogen and methyl, and then these are different. So we're gonna do our our parentheses, and I'm gonna put 2 because we're gonna start with this one first. So I see that my highest priorities are both on the bottom, so they're both gonna be Z. And then I'll do a comma and put 4. And I'm moving on to this one, and my lowest priority is on the bottom, and my highest priority is on the same side. So this is also Z. I'll put parentheses. And let's see, I think we will leave it like that. It looks good. So always check both of your double bonds for conformations. Even if, yeah, just check both of them, just to double check. Make sure that we got it. Okay, so it just says conjugated. It doesn't specify where my double bonds are, but we know that there's going to be, well, let's start by drawing this. So I have my 5, 1, 2, 3, 4, 5, and then conjugated. So I only want 1 single bond between them. So I'm going to go ahead and just do this one, 2 going to 3, and then I'll do 4 going to 5. If I was isolated, then I would move this double bond over here. Add my hydrogens, and lastly, it wants Z conformation. So I'm going to check which one. This one doesn't have any conformation because I have 2 hydrogens on the right, which means that there's no conformation. I'm going to go ahead and check this one. And what we see here is that we have our highest priority on the bottom and our lowest priority on the side on the bottom as well. So the highest priorities are not on the same side. So all we got to do is move some stuff around. This is probably the hardest part because sometimes it's really hard to move everything. Let's see. Oh, nice. So I'm going to roll it around. And although this looks a little bit funky, we still have these 2 on the same side. So that should be good. Okay, and now lastly we have our isolated diene with a 2-methyl pentane sigma frame. So I'll start by drawing my pentane. That signifies that I only have single bonds until I go and add those 2 double bonds. I'll add my methyl pentane, my 2-methyl, and then I'm going to go ahead and add some isolated double bonds. So I'm going to have 1 over here and 1 over here. So I just put that one here at the 4 position and then at the 1 position. And this is the 4th position because the smallest numbering scheme, we want the methyl closest to the number 1. So it would be 1, 2, 3, 4, 5. Add our hydrogens. And this is an isolated diene with 2-methyl pentane sigma frame. So I hope this lesson made sense. I tried to go as slow as possible. I know I can talk pretty fast sometimes. I feel like I have a lot to say. But good luck. Take your time, and remember, just keep a notebook with all the things. It'll really, really, really come in handy. But yeah, good luck.